In this video, I am going to discuss about plotting shear force diagram and a bending moment diagram for a simply supported beam having two point loads. Plot shear force and a bending moment diagram for a simply supported beam having area of cross section of 100 mm into 100 mm as shown below, material structural steel. So this is the simply supported beam. A and B are supported. We have a point load that is acting at CD points. Total span length of the simply supported beam is 2.5 meter. So we have to draw shear force and bending moment diagram using Ansys Workbench. So this is the analytical calculation. So reaction force at B is 3.2 kilonewton. Reaction force at A is 2.8 kilonewton. Shear force at A 2.8 kilonewton. Shear force at C 0.8 kilonewton, shear force at D 3.2 kilonewton and shear force at B 3.2 kilonewton. So bending moment at A and B are 0 and bending moment at C is 2.8 kilonewton meter and bending moment at D is 3.2 kilonewton meter. So this is the shear force diagram and this is the bending moment diagram. So we are going to draw the shear force diagram and a bending moment diagram using Ansys Workbench. So go to Ansys Workbench, select static structural, go to engineering data, the material is structural steel, click on geometry, right click, select design modeler, ensure unit is in meter, click on XY plane, go to create points, manual input 0, 0, 0, generate, again create points, manual input 1, 0, 0, generate, again create points, manual input 1.500, again create points, manual input 2.500. So 4 points have been created. So create line between these points. Go to concept line from points. Generate. Go to concept cross section rectangular. Generate. So minimize it. Click on model. line body material structural steel. Go to mesh, generate, decrease the size, elemental size. Okay. Then go to static structural. So we have 2 points. One is here and another is here. One is here and another is here. So here we are applying simply supported and here we are applying remote displacement. And these two are essential boundary conditions. In the case of beam, we have essential boundary condition and natural boundary condition. So here in this we are applying simply supported. Simply supported means all the translational motion will be arrested and there is only rotational motion. And here we are applying remote displacement. As the simply supported beam, here is a hinge joint and here is a roller support. So there will be movement in x direction and also rotation in z direction. So go to support, simply supported, here apply and go to remote displacement. So here movement in x direction, so it is free. So here in remote displacement we have a movement in x direction and rotation in z direction only. So go to force, apply components, negative 2000 Newton. Then again go to force, then solution insert deformation total. So this is the total deformation. Then solution, right click solution, insert shear force, bending moment. So this is the bending moment and this is shear force. Then for plotting shear force and bending moment diagram, we need a path. So click on model, insert construction geometry path, edges, okay. Then solution, insert beam result shear moment diagram path. So this is the shear force diagram and this is the bending moment diagram and this is displacement diagram. So you can see that this is the shear force diagram and this is bending moment diagram and here it is the displacement. Okay. Then again go to insert beam result, probe, reaction force, simply supported end, dashboard displacement. So this is a reaction at here. Here is remote displacement. So the force is 3200. 3200. And reaction force at A is 2800. Okay. So these are the result. Total deformation, total shear force, total bending moment, shear force and bending moment diagram, reaction force at A, reaction force at B. Okay. Thank you.